Hello everyone and welcome. So in this video I'm going to solve a couple of problems related to hydrostatic force lesson. Okay, so here we have a trapezoid and inside trapezoid we have water and we want to find the force exerted by this water on the cross section of the trapezoid. Right, so the picture is pretty detailed, so that's good. That will help us to set up the integral easily. Okay, right, so first of all they have drawn the slice and the zero is actually on the bottom. That's also important. Remember I said, okay, so the zero levels should be on the bottom. So the formula is force equal to rho g AD, right? Area times the depth. So now let's find the force acting upon one slice of this trapezium, the trapezoid. Okay, right. So rho is, we don't know, so let's keep it like that. Rho g, gravity, we don't know that. So what's the area of this rectangular slice? So the width is delta y, so that's good. What's the length? So see, in this problem the length changes based on where you have the slice, right? See, if you have the slice on the bottom, the length is small. If you have the slice on the top, the length is large. So how do you find the length? Length is actually depends on the function that you have on the two sides of the trapezoid. See, they are given. Okay, so you just take the difference of the function. All right, so that's the length. So the function on the right hand side, it's half y plus 3, and function on the left hand side is negative half y plus 1. So if you subtract these two just like I did here, that's your length, f minus h. Okay, so if I simplify that, that's gonna give me y over 2 plus 3 minus plus y over 2 minus 1. So y over 2 plus y over 2 is y. 3 minus 1 is 2. So y plus 2. So the length is y plus 2. So y plus 2 times delta y, that's your area of the slice. Okay, and then the height is, remember we call from zero level to the slice, that distance we call it yi. So the depth is the total distance, total height is 2, so the depth of the slice from the top is 2 minus yi. That's the depth. So if I organize this little bit, rho g y plus 2 minus yi delta y, that's the force acting upon this slice. So then the integral is going to be rho g y plus 2 minus y dy, and you are integrating from bottom to top from 0 to 2, and that's the integral. This integral will give you the force exerted upon this trapezoid, the entire trapezoid. Okay, so the key thing here is, I think the tricky thing here is finding the area, especially the length, understanding that it's the difference between the two functions. Okay, the length, and then from there you can find the area. All right, so I'm not going to solve the integral because the focus here is to learn how to set up the integral. Right, so let's look at another example. All right, so here's my last example for the video. So we have a circular plate inside water, and the radius, they say the radius of the circle is 3. Okay, right, so they have given us the slice. So let's try to find the force acting upon one slice. So rho g, that's fixed, that's density and gravity. Now we need area and depth, right? So for the area of the slice, you can see the width is delta y, so that's good. Now what's the length? That's the important question. So to find the length, actually I'm going to use a small trick. Okay, so here we have the zero level. Remember, they have given us the zero level here. Okay, if they have not given us the zero level, we have to do it by ourselves, but here we don't have to, because the zero level is the center of the circle. So from zero level to the slice, we always mark it as yi, that distance. So here's the zero level, so up to slice, that's yi, and then all what you need is this length, right? Length of the slice. Now I am going to connect the origin and the side, the end of this slice. Okay, if I connect it, this length is actually 3. Why? The radius is 3. If you connect to the end, it's the radius, right? So it's 3. So here's an idea. So if you want to find the total length of this slice, what you can do is you can find this half length using Pythagorean theorem and multiply it by 2, because this is a right angle triangle. So if you call this c square plus yi square is equal to 3 square. So c square is 3 square is 9, 9 minus yi square. So c is square root 9 minus yi square. That's the length of half distance from the center to the end of the circle. So if you want the total length, you have to multiply it by 2. So it's 2 square root 9 minus yi square. That's the length of the slice. Now the area is length, which is this, times delta y. That's the area. Right. Now the depth is, so water starts here. That's the beginning. That's the top. Okay. So that total distance is 7. And here this distance is yi. So the depth is this, right? So let's mark it from a different color. So this is the depth. How do you find the depth? Well, the total is 7 minus from 0 to here, it's yi. So it's 7 minus yi. So it's 7 minus yi. So that's the depth. So now you can write this as the integral rho g. 2 I'm going to take it in front. Square root 9 minus y square. 7 minus y dy. Now integrating from where to where? So from bottom of the object to the top of the object. You want to find the pressure on the object, not outside, right? So bottom of the object is -3 because the radius is 3 to the bottom, and you're going from the -3 and the top is 3. Okay, the top of the object is 3 because 0 is in the middle, so the top is 3. So you're integrating from -3 to 3. So this is the integral that will give you the force, okay, acted upon this circular plate because of water. Now important thing here is that you have to remember you are finding the force acting upon the object. So the limit belongs to the object. Now when you find the depth, you're talking about the depth of the slice from the top of water, not top of object, okay, where the water is in the top, okay, because water is the one that's acting force on the slice, okay. So depth of the slice, okay, from the top of water. So that's why it's 7 minus y, not 3 minus y, okay, right. So yeah, that's how you set up an integral. Couple of examples related to hydrostatic force. Okay, all right, so I'll see you in another video.